Okay, hello. Welcome to Bangla Quantum Computing, study session on Intro to Quantum Mechanics, mainly on Griffith to admin stuff. Basically, I am updating regularly an Overleaf page. I think I shared the link with Tanvir and Deepto. Okay, that is the admin stuff. Let me know if you have any trouble on accessing to the Overleaf account or Overleaf page where I am updating regularly what I'm going on and what we are going to do. However, for these sessions, we will mainly talk about probability density function. That is our main goal. And on Griffith book, they describe the probability density function by discrete variables and continuous variable actually. And if we have end of the session, we'll try to solve an exercise in mainly from an example. Okay, let's talk about discrete variables. Discrete variables are the numbers are discrete or not very continuous, like let's say 1.2222, 1.2345677. This kind of number, they are very continuous actually. But discrete variables are very discrete. There are some interval or some difference between discrete variables. In Griffith book example, they showed an example. They consider age as a discrete example. They provide a set of people age, and they call it, let's say, Nj represents number of people of age J. J is the variable in here. Let's say when you say n of 14, it says that what is the number of people that has age 14? It has one from this set. What is the number of people that has age 16? It has three people. What is the number of people that has age 25? It is five people actually. So in here, J age is the discrete variable, and you can represent this like this way. And if you total sum, because this variable is giving you total number actually, the summation of this is the total number. And right now, if you want to try to plot a histogram, and based on this, what is the number of people of that particular age J, and you will find that if you try to analyze this histogram plot, here J is the variable for age from 10 to 26. Here we can see that 25, age 25 years is the maximum number people have. It has five people that has 25 years old. And 22, that is 22, 24, and 16. From here you can see 16 years old people. There are three peoples, those who have 16 years, two peoples, those who have 22 years, two peoples, those have 24 years, and one people has 14 and 15 years actually. So right now, if anyone asks you to calculate the probability of a particular age, let's say for example, what could be the probability of, let's say randomly you are selecting a person. Probability is something like just randomly you are selecting a person. There should be some random choice. It is probability. Usually on random choice, you are selecting a person. What could be the probability that person has age 15 years old? So to do that, the way usually we do that actually, probability formula is on numerator. On numerator, there is the possible choice, and on denominator is the total choice. So here we can see that let's say if we try to solve this example, probability of J, that means probability, there are some I think mistakes actually. Yes, it has some mistakes actually. I mean, it got confused. They try to solve 15, but they are explaining all those things. But we can get the overall idea. So probability of J, that means probability of finding a particular age. From here, this distribution, you can say, let's say for 14, there is one people that has 14 actually. And what is the number of this total actually? And there is total 14 people. So out of 14, only one people has 14 years old actually. So probability of finding a 14 years old person is 1 by 14. Let's say what is the probability? There are 14 group of 14 peoples in this group. You are randomly selecting a person and it asks you what is the probability of that person having 16 years old, having age of 16. So in here, you can see that there is 3 people that has 16 years old out of 14 people. So 3 out of 14, that means 3 divided by 14 is the probability of having that particular person age of 16. Let's say, for example, it asks you to, what is the, you are randomly selecting person from this group. This group has 14 people, and what could be the probability of that particular person 24 years old, age of 24. That means there are 2 people out of 14, 2 divided by 14. That is the probability of that particular person could be 24 years old. So that's how we can calculate probability. So what we can say? We can say that probability of J, that means probability of getting an edge J is on numerator, that is the Nj. Nj means the number of people that has that particular age, that is Nj. We defined Nj on previously, and denominator is the summation of total Nj. So that is the probability. You should get the overall idea that what is the probability and how we are describing the discrete variables. And one thing we all know, that summation of all probability should be the one. So that is the thing from, let's say, probability of finding a person that has age 14, some probability of finding person that has age 15, age 16, age 22, age 24, 25. If you try to do sum for all these categories, you should end with 1. So it is universal. You all should we know that probability cannot be easily greater than 1 actually. It should be less than or equal to 1 actually. Okay. So, and here is another questions. If it asks you that probability of either getting 14 or 15, what could be the probability? Let's say randomly you are selecting a person from this group. This group has 14 people. What could be the probability that person is either 14 or 15? In that case, what you should do, probability of finding probability of that person age of 14 is 1, because one person has age 14, divided by total people, that is 14, 1 by 14. And probability of finding a person age 15 is 1, because in this group only one person has 15 years old, divided by total number of people. That means 1 divided by 14. So 1 divided by 14 plus 1 divided by 14, that is 2 divided by 14 equal to 1 over 7. So that is the probability of either that person age either could be 14 or 15. So you should do sum of individual probabilities. Okay. And right now, if we want to average, let's say, what is the average of this group, average age of this group of 14 people? So how do we do the average actually? The usual way of doing average is take all the sum divided by the group actually. Let's say how many people has age of 14? One people. How many people have age 15? One person. How many person has age 16? Three person. You are doing the sum on numerator and you are dividing it by total number of people, the 14. That is 21 actually. So right now, if you want to give a mathematical expression for this, to do that, the average, that is the symbol for average. You'll find almost all mathematical books, mathematic related books or articles, and if you go in future research on quantum mechanics, you'll find that's how people write average actually. That is the usual expression for the average. Another thing people sometimes try to call that is expectation value actually. Yeah, they mention it, Griffith mentioned it. So in quantum mechanics, it is also called expectation value. Okay, so here we can see on numerator that is the summations of total group. I mean total age actually. So what we are getting, that is the age, J. We define J is the variable age multiplied by number of people have that particular age. We did these things. That is the summation divided by n. That is the total number of people. And J, Pj. So we define that P of J equal to n of J divided by n. You can see that is n of J divided by n. That is probability of finding that particular, probability of having that particular person of age J. Here I'd like to say important things actually. This week I was having a lecture on quantum mechanics actually. So suddenly this term came. So for a moment, whole class got confused how you can write that average is equal to J multiplied by probability of J. That means your variable, J could be any variable, discrete variable, and for probability of finding that variable. So that is the general term actually. It was written in X, probability of finding X. That is the summations actually. I mean, professor took some time to convince the class that, okay, this is the way you can write actually. So yeah, on PhD level, sometimes people get confused. So I will say, yeah, it's good that at this age, when you are in undergrad or bachelor's level, you are already have some understanding. Okay, this is the things on going on. Okay, any confusion about average, because this is very important concept. You will see the expectation value term a lot. Okay, so for any confusion, I'm not sure if anyone is waiting. I don't think so. Okay. Okay. Let's move on. So what is the average of this square? So squares of the edges. So that means it asks you to calculate the square of the edges. That means look at the term. What does it say? It says squares of the edges. That means you should square your variable. That means your variable is j, you should square it and you should average it. How you can do that? Just put the average square and you know the probability of j. If you do the sum, then you will get the average. So that is the average formula, but it asks you to average of the square of the edges. So that means do the square over the variable j square, then p of j, probability of finding that particular edge, then do the sum, you will end with square of the edges. And they try to make it a general for the average value of function of j is given. So that is the general formula. So I just I have a questions, and that is a kind of, I would say, exercise. I wrote exercise for you. I'm trying to guide you how you can solve that. Let's go to the exercise. Uh, you can see my overlap screen, right? Uh, 3 exercise 1. You can see my screen. Hello. Oh yeah,
Actually, no.
cannot. Let me try one more time. Stop sharing screen to. Okay, your screen sharing. It says you can see my screen. Uh, Exercise 1. From a Gaussian distribution, that is a mathematical expression. Don't worry about it. But it says show that average of squares greater than, if you do the average and square it actually. So this is the Gaussian distributions actually. So try to solve this problem, but I can give you a hint. One of the hint is that you may need to calculate a, and you can see that basically Gaussian distribution, if you want to solve this problem, you need to calculate the value of a. I did not give it, I should update it. This is a constant. The value of a, I think, square root over pi by lambda actually. I'll check. But I think a is square root over pi by lambda actually. What you need to do, you need to do the integration over this actually. So once you do the integration, because summations is quite equivalent to the integrations actually, then you will get the average. Then once you square it, and another approach you have to do, once you have the average, that is your variable, you just need to do x square actually. So try to do that. It will give you some idea, okay, this is the way you can do average of the square. And if you have any question, yeah, just keep discussing. Uh, let's check. Let me share my screen one more time. Leave it is sharing. Okay. Okay. So far, we defined the average. Okay, we defined the average, how we can calculate the expectation value. That is the summation of the variable and probability of finding that variable. Value of the variable. Yes. And here is the important concepts actually. It is the variance of a distributions actually. You'll see infrequently in quantum mechanics, people use term probability distribution or random distribution. If you work on photonics, you'll find two specific terms, Gaussian distribution, and another term is Poisson distributions actually. So when people try to solve or analyze Schrodinger equations on quantum mechanics, they frequently use these two terms for photonics, Gaussian distribution and Poisson distribution, and probability distribution is a very common term in quantum mechanics. Okay. So we need to understand what is the variance of the distribution. Variance means how it is spreading, from the average actually. So let's use some common intuition. This is your distribution. This is distribution 1. This is distribution 2. Which one is spreading more just in your naked eye? Which one do you see the spreading more, 1 or 2? You can write in chat box or unmute yourself. Yeah. Okay. Yes, 2. So you can see this is spreading more actually. So that means if we want to calculate the variance, the sigma value, it will have more value actually. So we want to calculate how it is spreading. Usually in photonics, we want to get a narrow peak actually. Let's say for single photon. If you want to analyze single photon, that means this should be very narrow actually. You'll see on laser or on LED, people use this kind of distribution term, and it should be very narrow actually. Because if it is spreading, that means there's other photons amplitude or photons peak actually. You are getting some peaks. But if it is very narrow, that means you can assume, oh, okay, because in experimental, there are some issues. There are some experimental challenges you will face in the lab. But if it is very narrow, then you can say, okay, I'm getting a single peak actually. So yeah, that's what we want to aim for. That's why distribution is important. And you also need to analyze the variance of that distribution, because how you are spreading. That means from the average, how far you are from. How far you are from the average. That means you are not doing very well. Okay. So that means I have a value of a variable that is j. In our cases, our example, that is age. That variable is age j. That is a particular value of that variable, how far it is from the average. That is the mathematical expression. That's what it says actually. So let's try to do the average of this. If you want to do the average of this, like we said, just this is our function, that is j minus claim it. That is I just wrote down this function. I mean, they just wrote down this function, j minus average of j, how far it is from, probability of finding that particular value of that variable. So this is on the parenthesis, just distribute it, j p of j, then average, because average is already function, you can take it out of the sum, that is p of j. Who can say what is the value of this? What is the value of summation of probability? You can type down on the chat or unmute yourself. Yes, that is 1. Because we know summation of probability finding a value. I mean, if you do the summation for all of them, you will end with 1. So that means this is 1. So you are ending with expectation value in here. And we already have seen these things, because that is a variable j, value of variable j, and probability of finding that value. Summation of this is the expectation value. So that is j minus j. So what does it say actually? It says this expectation value of the spread. We can define this term is a spread actually. expectation value of this spread is 0 actually. So does it make sense actually? I mean, what you are doing, you are doing this is a spread, let's say on this distribution. Uh, okay, I'm considering this is a normal distribution. Usually in normal distribution, that is the average value. In here, you'll find the average. So let's say, for example, this value, the value of j in here, I mean, usually in here it is j, and that is n of j. Okay, so if, oh yeah, I think you are Rifat. Rifat, go ahead. You have a question? Yeah, you speak in Bengali. I just trying to record it in English so that other people, international people can listen to it actually. Don't worry. Yeah, go ahead. Rifat, you raised your hand. Do you have any question? You can type down in chat if you have question.
ও সরি সরি আই ওয়াজ মিউটেড। আচ্ছা, এইখানে
Okay.
আপনার হচ্ছে, সরি সরি, একটু মিউট ছিলাম তো আমি বুঝতে পারি না, কথা বলতেছিলাম। ওকে, এইখানে আপনার ওই যে ডেল্টা জে হচ্ছে আপনার যেহেতু একটা ইন্টিজার না, আর হচ্ছে ওইখানে আপনার ব্র্যাকেট দেওয়া আছে, তো ওইটা তো আপনার হচ্ছে কিউবিটের স্টেট বোঝাচ্ছে অনেক দূর। আচ্ছা, ইন্টিজার থেকে হচ্ছে যদি একটা স্টেট যদি আমি বিয়োগ করি, জিনিসটা অ্যাকচুয়ালি মানে কিভাবে ক্যালকুলেশন গুলো হচ্ছে ওটা একটু যদি বলতেন।
Oh, first of all, this is not qubit state. We are still not any close to defining a qubit state. Yeah, we will define qubit state later. Qubit state later. This term, I think you have a question. You are trying to refer that this is a qubit state. Qubit state, you are trying to refer it. Uh, no, this is right now, this is not a qubit state actually. So this is an average of variable of j. So, and that is trying to say that you have a value, you are randomly or you are just choosing a value, that value is j, how far it is from the average. That means you have, let's say this is your average on a normal distributions. You are choosing a value j, and how far is it? That is your delta j actually. So no, this is not a qubit state actually. And on expectation value in quantum mechanics, people use expectation value. Okay, from my side, I work on photonics actually. You will get, once you detect photons, because like I said, your main goal to get the quantum property from the photon is mostly single photon. So once you have single photon, you detect it using photodetector, then you'll get a distributions. And the average of that distribution is the expectation value actually. But still, that is not a qubit state. Qubit state is the single photon you created actually. That is your state because you are doing calculated for, you are doing your computation for that single photon. I mean, using the single photon actually. So yeah, I'll say no, that is not qubit state. And I'm trying to say that uh, if you have average, that is your average on bracket, and you have a value, you're choosing a value that is j, and how far this value from this actually. And the average of that j, okay, yeah, someone has a question. Okay, clear, thank you. average of that j. That means how far it is spreading. So what you are trying to do right now. So if you try to make all this average spreading, let's say randomly you are choosing the value actually. What you are doing, you are randomly choosing some values. And this is your average. If it is symmetric, most of the cases it will be symmetric actually. I mean, in simple cases it is symmetric. In simple cases it is symmetric. In asymmetric, you can also find these configurations actually. But let's say consider usually normal distribution is symmetric, but there are some skewed normal distributions actually. For simple case, let's say this is symmetric normal distributions. There is no skewing. I mean, there is no, when I say skewing, that means uh, something like this. I think this is positive skewing. When it is negative skewing, it will be something like this, not on the middle. You can see the difference between these three distributions. Okay, uh, let me clear the screen a bit. It will be helpful to explain. Okay, so this is your average. If you see, there are some positive because this value is j, negative, that is your average, that is j. And how far it is spreading, because this is positive, I mean, this will be greater than 0. The same amount, but it will be negative because that value is greater, negative of j minus j. So that value will be greater because what you are calculating how far a particular value j from the average actually. So there is positive value because here j, this value, just a value of j, variable j, is greater than the average value. And in here on the left side, the value of j is less than j. So that means one side it will be positive, one side it will be negative. And you are doing the average. Once you do the average, that means you sum all cases. You are summing this one and this one. So equal sum will end you to the 0 actually. I believe you got the intuitions what is happening. Okay, Jubair, you want to say something? Uh, you can write down in the chat box. Uh, okay, let's keep moving. Okay, so that is the average of j of the spread in a distributions. Right now, if we square it, you just square this variable, the spread, and then do the average. Square of the spread, average of square of spread. That is the variance. That is the sigma. So, and I mean, sigma square is the variance and sigma is the standard deviations. And you'll find this term very frequently in normal distributions. Okay, let's see the questions. Um, oh, you mean average of delta J? Okay, broadly when I was explaining intuitively how it is happening. Okay, let's try to use a bot. I believe it will be more helpful. Where is the bot? Does okay, I found the whiteboard. I believe you can see my whiteboard. Okay, where is the whiteboard? Okay, you can see the whiteboard. Okay, let's consider a normal distribution. Let's consider a normal distributions. I'm considering just a symmetric normal distributions. This is a symmetric normal distribution. In here, that is your variable j. These variables have some value and number of j. number of that value you are getting. That is n of j actually. And usually that is the average. Usually a normal distribution, this is your mean, this is your median, this is your mode, all those things. We are just thinking about right now mean, not median, not mode, some other parameters in statistical distributions actually. So that is your mean, that is your average actually. And we defined that j like this. Let's say you are considering this value of j actually. So you can see this value in j, obviously it is greater than average value because this is on the right side. You see, because it is increasing. The value of j in here, it is increasing actually. So if you try to j minus average j, so that means your delta in here will be positive. In here, your delta will be positive. I believe you understand that because in here j is greater than average value of j. So that means this value will be positive. And in here, and that is another value, that is j actually. The spread delta, this one will be negative because j minus average, this one will be negative because in here your j is less than average value of j. So right now you are trying to do the average of this delta. So if I want to calculate the average of delta j, that means what I have to do, I have to sum for this distribution. I mean, from here to here, this is my distribution plot. From here to here, I have to sum for all the cases actually. What you can see actually, if I try to sum for this value, this value, this value, this value, any value of j on the right side and left side, you'll see from the right side, it will be positive, equivalent value, but in the negative, on the minus sign, you'll get on the left side. How we do the average? We sum all of them, right? And then divided by the total things. So if you want to do the sum, there are some equivalent positive and equivalent negative. What will be the summation of this case? It will be obviously zero, right? So yeah, spread, average of the spread should be zero. Does it make sense right now? Rifat?
বুঝতে পেরেছি। ওই যে আরেকটা যে ইকুয়েশনটা আছে না, ওই যে উপরেরটা ঠিক, ওই যে আপনি আহ, একটু যদি আপনি একটু ব্যাকে যান আপনার পিডিএফটাই।
Okay. Okay, let's share the screen. Mm, I believe you can see, right? What is it? Let
এই
me
যে
share.
আচ্ছা এসেছিল
Okay. Okay. Equation 1.10 or 1.11? Which one you were talking about?
1.10টা, ওই যে আপনি এখানে যে এক্সপ্যান্ড করলেন ইকুয়েশনটাকে, যে ডেল্টা জেড নিচে নিচে নিচে।
Okay.
হ্যাঁ,
এটা
এটা
oh,
এখানে যে এক্সপ্যান্ডটা করলেন, এক্সপ্যান্ডটা কিভাবে করছেন এটুকু একটু
oh,
বলবেন?
okay. So when you try to, so okay, from this symbol we can say we want to do the average of spread, that is delta j. So that means summation of delta j multiplied by probability of j, probability of that variable. So this is the function we defined actually. It doesn't matter. It could be any function of j. It could be j square, j cube, delta j, absolute value of j, uh, j factorial. It doesn't matter. That the average value of function of j, it should be function of j multiplied by probability of finding that value of variable j. So we are doing the same thing. That is our variable spread j. I mean, that is our function spread of j multiplied by probability of j. And then, okay, I was looking for an annotation. Okay. So this is our function of j, that is delta j. If you want to do the average, that means summation of function of j multiplied by probability of finding that variable, value of that variable j. So in our case, function of j equal to delta j, that is summation, that is delta j multiplied by p of j. So once you have delta j, that means I'm just plugging equation 1.1 into in here. That means this one, p of j. Right now I'm distributing, if you want me to, that is variable of j, that is p of j equal to what I can write. This is on the parenthesis, so that means I can write j multiplied by p of j, then minus average of delta j of p of j. So we are in here. So this term means we already did the average. So we don't need to average of average. I don't know anything if there exists actually. So we are taking it out of the sum actually. So that means the only thing in this second term exists is summation of p of j. And we know probability, summation of probability for all possible cases, it should be 1. That is 1. I mean, this term, that is 1. So if it is 1, so average of j multiplied by 1, that is j. And we have seen this term actually, that is the average for j. And if you subtract that, you'll get 0.
Yeah.
Any confusion right now?
No, no, clear, clear. Thank you.
Okay, good. H. Okay. So, okay, this is our distributions. We got our so we have our standard deviations. We define sigma square, that is the average of the spread. I mean, average of square of spread, because that is the spread. We are squaring, then we're doing the average. That is the variance. Okay. And sigma, square root of variance, is the standard deviation. Square root of, you need this term a lot when you try to, I believe in undergrad, I mean, when I'm from electrical engineering background, so I had a statistical course actually, so it gave me a very hard time actually for understanding the standard deviations actually. So standard deviations, you can see the variance, that is the square of average. I mean, average of square of spread. It gives you variance, and the standard deviations is square root of that. Let me share on just for once again, we have this normal distributions. So this is 1 sigma from normal distribution, mean to mean. This is 1 sigma. In here it is 1 sigma. And here it is also 1 sigma. From average, in here, this is 2 sigma. From average, this is 3 sigma. It is also from average on the left side. Let's say this value in this distribution, I mean, in this range, they fall into 2 sigma distributions. They also fall into the 3 sigma distributions. What does it mean? 1 sigma, 2 sigma, 3 sigma. You'll frequently find that when people say statistical for any, I mean, especially normal distribution or Gaussian distributions, they will frequently use these terms. Okay, this is standard deviations. You can just try to, I mean, when is people say standard deviations, they try to say how far you from the average. 1 sigma means you are quite close, because you can see this range. If this is in the 1 sigma, you are quite close to the average. If you say, okay, 2 sigma, you are very much off from the average. This is 3 sigma, that is also very much off from the average. This thing also used from, let's say you are working on a chip design company or any other fabrication or production company. You have some default actually. You have some standard value that is, let's say, for your average value. And when you try to check quality check, people call it QC in the industry, you have some average value, and each time for every single production you do the quality check actually for us. Every batch of production you do the quality check actually, and then you try to do the average. Let's say your company or your production has some average, has some standard, and for a particular production, if it is 1 sigma off from the average, I mean, if you say your standard deviation is 1 sigma, then you can say, okay, for this batch of production, your quality check value, let's say quality check value is, you can say, quite close to the average actually. So it's your decision, either you will accept it or reject it actually. It is the company standard protocol. Based on the company protocol or your production protocol, you can either accept it or reject it actually. So this term 1 sigma, 2 sigma, that means how far you are from the average. That is the intuition. You can get the idea, okay, I'm very much off. If it is 3 sigma, I'm very much off. This is the thing also used in the, let's say, in a set of class. I mean, one thing people say, I mean, you will find some jokes that almost everything in the world, uh, Gaussian, I mean, every distribution in the world, Gaussian distribution is followed. Let's say, given one example, in a class, you will find some students are extremely well, are very good. They are in this outlier. Some students are terrible. I mean, they just struggle to even pass in the exam on that sense. And this is the range where most of the students fall in. They are average, actually. They are the average. So those are the outlier. Those are the, this is the extreme outlier, those two, and this is the average. So it is mostly used in the university when some, let's say, uh, they do the carving. When they do the carving, they try to say, let's say you have an exam, professor took an exam, and they try to distribute the grade of the students actually to get the idea how the students did. Obviously, you will find one or two students there really very well. You'll find one or two students that did very terrible, and you'll find the average. So then they do the distance. Okay, from the average, how far the extreme outliers actually. Then the professor can took the measurements. Okay, this is my average. My outlier, the extreme value, it is very 3 sigma value is very far from the average actually. So that means most of the students are failing to understand what is going on. So I should take some extra steps so that they can understand actually. Uh, Usually it is widely accepted norm in the university class to get the feedback from the students how they are doing actually. But yeah, that is the statistical distributions. That is the basic. So what did we learn so far? We learned how to calculate the average. We learned what is the standard deviation, and what is the variance. Sigma square is the variance. So similarly, that is the theorem actually. That is the sigma square. What is the sigma square? Sigma square is the average of the spread, square of the spread. Okay, let's go one by one. So what is the average? How we can write the average? That is the sum of the function. In this case, function is the spread, square of the spread multiplied by probability of that value. So we know the spread of j, that is j minus average, that is the value of the variable minus average of that variable j. You have the square. So right now, a minus b whole square formula, a square minus 2ab plus b square, then p of j, then j square p of j, then 2j, those are the constant, you don't need to do anything. There is j, p of j, then average of square, then p of j. The summation of probability is 1, so you will end with j square. And then j of p of j, that is also, okay, that is also average of j, then j square. You see 2j average of j, then square. 2 average of j square, that is negative, plus average of j square. So that means that is minus 2, that is plus 1. You will end with minus average of j square. So that means you will end with these terms. Is there any confusion to what is going on in these expressions or these formulations? Okay. Oh, good.
No, ভাইয়া, it's
Okay.
okay.
Okay. Okay. The exercise that I was trying to say, basically you have to calculate sigma square. What we ended with? We ended with j square minus average of j. There are two different terms. You see, one is square is inside the bracket, that is square of edges, and it is average. Average of square of edges. And that is, okay, I repeat, this term, average of square of edges. And this is square of averages. You see the difference of term, how you should read from this actually. I repeat, average of square of edges. This is square of averages. So you standard deviations, if you try to do, I did not do anything. I just do the square root. That is the standard deviations, sigma actually. If you want sigma to be positive, greater than 0, what I should do? I mean, if I want to my standard deviation to be positive, what I should do? What does it say, this expression? It says these terms should be positive. How a minus can be positive? That means it should be larger. The first term should be larger than this one, right? If this is larger than this one, that means, which is this term? That means average of square of j, my variable, average of square of my variable, then square of edges. That means it should be or equal to, I mean, this term should be greater than or equal to j. Only this case, this will be positive. Otherwise, it will be negative. You will end with some imaginary term, because if the minus of imaginary term, I mean, you cannot do the square of, I mean, you will end with complex term actually, that is the I. So to be the positive, that means you need, I mean, obviously it should be, this is the formula, this is, I can say law actually, that from there you can get the idea that average of square of a variable always greater than square of averages actually. So yeah, that is greater than. So that is the exercise that I was trying to say. So you need to calculate these standard deviations, and then you will find that okay, this holds, this relationship holds. This holds true. Okay. Any confusion?
এটা কি একটু গ্রাফিক্যালি দেখানো যাবে, এই যে আপনার স্কোয়ারে যে জিনিসগুলো?
Okay, let's try. Um,
জাস্ট
okay.
এই জিনিসটা, ওই যে গ্রেটার দেন যে দেখালেন না, মানে এটা
Uh-huh.
হচ্ছে গ্রেটার দেন, এটা হতো এটুকু জাস্ট।
Okay, let's clear all my drawings. Clear all drawings. Okay. What we're trying to do? We are trying to do, okay, let's write the formula at first. That is this. This is the formula. And from here, we just wrote this. That is average of square of a variable. And that is square of average. And from there, I can say if I want these things to be positive, from there we ended that it implies that that is the correct mathematical way to say. It implies that this implies that okay, we want to see that in distribution. Okay, one thing, this is my average. I said this is 1 sigma. This is also, I mean, in on the right side and also in the left side, this is also 1 sigma actually. So that's the standard deviation. And what does it say actually? First of all, we can attack this, we can try to understand these things in two ways. First is 1 sigma, I mean, the sigma standard deviation should be the positive. Because what you are doing actually, when you are calculating the variance, the sigma square, one of the reason we try to do the sigma square, uh, we try to get the positive things actually. We try to get only the positive because when the reason we try to do J average, uh, this is the J average, and once we do the square, we take the all the positives actually. It could be I mean it could be anything. Let's say you have some average of negative values. Let's say you have some average of the negative values. This I'm trying to referring these portions. If you are trying to do the average on these things, I mean only this the left portion, you will end with some negative values actually. In this case, your average will be negative actually. So one of the reason we do square so that we can just consider the positive values actually. Okay. And that is one comment. When we're trying to do uh, j square, that means this is my variable j on the x-axis. This is my variable j on the x-axis. I am squaring it. I'm just squaring it actually. I'm not doing anything. I'm just squaring it actually. Uh, okay, I don't think you can give me a second. Let me think. Okay, it will be quite difficult to explain the way I'm thinking. The best approach would be to discuss with the standard deviation. Wait a minute. Okay. Uh, in this is my average. I said this term is sigma, that is 1 sigma, and I also said that the on the right side you will get this range. Your values are in the 1 sigma. On here, your values in also in 1 sigma actually. So what does it mean? This is symmetric. in simple cases, we are considering this is the symmetric values actually. You are randomly choosing, let's say, any value. This value is j. Let's say you are randomly choosing any value actually. You can choose it on the left side, you can choose it on the right side. It doesn't matter. The sigma is the distance from the average. When I say distance, I mean it, let's say, how can I say? When I say distance, let's say this is your starting point. You are ending into this. You can also end into this actually. When I say 5 meter, I am not saying that it does not give you any details idea that which side are you. Either are you at right side, either are you at the left side, because this is just a uh, distance or scalar value. This is not a vector actually. That's why sigma is the positive. Let's extend this idea in the distributions. This is my how we are ending with sigma square variance or sigma. We are ending into sigma from the spread, how it is spreading, how far it is from the average value actually. So that is my starting point. You can take any value on the right side or you can take any value on the left side. It tries to give you an abstract idea from the sigma value. What is the distance from the average? It could be on the right side, it could be in the left side. It does not tell you what is the value of j actually. It only tells you that's the distance only. So that is one intuitive idea that's why it should be always positive. I believe you are trying to ask me by referring this term and this term, try to explain this, that this is positive. Right now, I will say, okay, maybe next session, I mean the next week on Saturday, 11 p.m. Bangladesh time, I can explain it. Give me this week to look into it, how you can explain it. But for now, I can say that your sigma means it is the distance. The distance could be any directions, in this way and this way. It does not tell you where are you and where are you going actually. Does it make sense? For now, just for now, why sigma should be positive, and from there, it should be mathematically greater than, I mean, this relation holds true.
Okay, guys. It's okay.
Okay,
Carry.
okay, okay. Okay, let's try to finish in 5 minutes. I had planned to go to the continuous distributions. Okay, they just say it actually. When sigma is zero, the distribution doesn't spread at all actually. So this is all the things actually. Okay, it is continuous variable. That is the sigma x actually. That is the rho x. It tries to say, I mean, the in previous case our variable age was a discrete variable, and if it is continuous, that means it is continuously going on, that is no discrete. Usually, okay, yeah, that is no discrete, that is rho x. And when it is continuous variable, usually in discrete case we do the summation, and continuous variable we do the integration, because the infinitesimal dx, we know dx tends to 0, because the distance between x and dx, x plus dx, is limit tends to 0. So we need to do the integrations. If you want to do the integration over this, it will end into the 1 actually. So from there we can say we can do the same things actually. Average of x variable This is my distribution, probability distribution, x multiplied by rho x of dx. You can the rho x dx, that is analogous to the probability, because we have seen this term actually, because like I was saying, when it is discrete we do the sum, when it is continuous we do the integrations, and the integrations of minus infinity to the zero of this probability factor, actually proportional factor, that is the probability of having a yeah, that is the probability density, probability that variable x lies into minus infinity to plus infinity will be 1. Average of this is x, rho of x, and in any case that is also true. The standard deviation also holds true. Okay, that is a math actually. What does it do actually? Let's say uh, a rock falling from a height h, that is a continuously falling. There is no discrete things actually, and you are taking photos actually. And when we are taking photos, each time you take photo, randomly you are just shuttering the camera actually. You are taking photos. That means each time you are taking photo, it is covering some distance actually. So what is the average of all those distance? You have to calculate that. It asks you to calculate that actually. So we know when something's fall from the distance h, we know the distance x equal to half gt square, and it has time variable, that is t. Okay, so right now we are doing the differentiations. Basically, that is differentiation dx over dt, that is gt. And from I think from high school, I believe, or college, the total time it is taking, that is square root over 2h over j. So that means during that time, during the total time, that is my t, I have to find the probability that a particular photograph is taken. That means how we can find the probability of a particular time, that is in dt. That means dt on numerator divided by the total actually. So dt over t, and in that probability, what is the probability of that the rock covered a distance dx actually. So dt over t, what it is doing actually, dx over dt. Give me a second. I'll just quick. We have dx over dt equal to zt. What we did, we have dt over t. Okay, dt over t actually. This is the probability of any particle, because you are randomly uh, taking the photographs. You're randomly taking the image, taking the image of the rock falling. So that is the dt, and that is the total time. That means that is the flat time it will come to the ground. That is the t. So dt over dt. Okay. And you also know t equal to square root over 2h over j. So what I'm going to do, I know dx over dt equal to zt. I'm doing dx over z. I'm just taking it to the below. Dx over gt equal to dt. And my, oh, just wait a second. I'm scrolling down. Okay, I think, yes. Okay, so you are trying to calculate dt over t actually. So your uh, what you have, your dt over t. your dt value is dx over zt. That means your numerator, that is dt, equal to dx over zt multiplied by 1 over t. I mean, you just wrote it actually. So dx over gt multiplied by 1 over square root over, you just have this formula, 2h over g. So you have that things. If you do some just I mean, this square root over g will top, then it will be square root over 2g. You will find this term actually from here. And then this is your probability distributions actually. This term is your probability density functions actually. How it is probability density functions? Because it says in dx, what is the probability? I mean, okay, let's go on there. If you try to analyze rho x multiplied by dx, that is the probability of finding a value or in between x and x plus dx, rho x and dx. So you have dx in here, so that means it should be rho x. Right now, what you are doing the integration from 0 to x, then it should be 1. If you're trying to do the average, that means x, rho x dx, it will be h over 3 actually. So that means this is your probability density and it is following x. We can try to solve this in more details, but you can try to solve the problem 1.1. I took the problem for the Gaussian distribution from problem 1.3 actually. So yeah, you have to calculate all those things. Sigma, you have to show the sigma is greater than 0 actually. So from there, you can say that average of square of variable x is greater than square of averages. So yep. Then on the next class, we will go to the normalization, how to do the normalizations. Then we will discuss momentum, and there is some uncertainty principles, I believe. Yeah, and I will, after end of chapter 2, I'm not sure. My plan is to keep continuing this session end of the November. I mean, then, okay, let's just stop for a moment. Then you can discuss some things. But for now, today's session is quite off. I am stop recording. Just wait a second. How can I stop recording?